This is Truth Be Told.
That not only are there reptilians here,
new evidence of UFO fleets.
We were close to nuclear war.
To help you transform so that you can live your highest truth.
We're not being told just because we're not ready for it.
Geostations of frequency, vibrational.
I was a homicide detective with LAPD.
UFOs increase, visitations. Space, the final frontier. Those are the words of Captain Kirk. But in the 1960s, I don't know if Captain Kirk really understood how many galaxies and worlds that are really out there. With the new discoveries of images from different galaxies, universes, thanks to James Webb Telescope, today we're going to speak with Dr. Michael Summers. He's a professor of physics and astronomy at George Mason University. He's going to give us some details of what the images mean for us and our future, and what other opportunities that we have to answer the question that has been going on for thousands of years. Is there someone else out there? Today we're going to find out more information. So I'm Tony Sweet with Truth Be Told. Please welcome to the Truth Be Told studios, actually for the second time, we have author and professor Dr. Michael Summers. There he is. He's back after about 5 years. How we were just saying before, it's been 4 or 5, maybe even 6 years since the last time you've been on. And right. Wow, what a difference time can make.
Yeah. I tell you, the launch of James Webb is almost like a life-changing event. I mean, it's maybe not like having your first child, but it's pretty close. I mean, I think that a lot of astronomers are going to start talking about pre-James Webb and post-James Webb.
Right.
That's sort of two different views of the universe that were given by the telescopes we have access to.
And I remember the last time we talked, you even said, 30 years ago, maybe 40 years ago, we thought there was just, very few planets out there, not even that many galaxies. But now, I mean, before James Webb, we thought there were, probably hundreds of thousands, maybe millions. And now it's like unlimited.
Numbers are hard to wrap your mind around.
It is.
I mean, if you just take the stars in our galaxy, 300 billion, that's like 30 times the number of people that have ever lived on Earth. So every person that could ever live on Earth had 30 stars, but that's just one galaxy. Wow. We think that there are trillions of galaxies. And so, every person that could ever live could have 1 trillion stars. And then we're seeing that exoplanets, planets around other stars, are so commonplace that on average, when you go out and look at the sky at night, every star is going to have somewhere between 5 and 10 planets. And that means every star in the galaxy and probably every star in most of the universe. And I worked it out, and the number of habitable planets in the observable universe is about 10,000 times combined number of heartbeats of all the people that have ever lived on Earth.
Well, if you're listening to the podcast, if you go to the YouTube channel, you see the opening. There's an alien staring at us, and what's fascinating is a lot of people are like, are there or are there not? Well, this is proven. They may not necessarily look exactly like that, but there's definitely something out there, because there can't be that many planets, and we're the lone planet in all these galaxies to have life.
Well, in science, you have to have really, really good proof or evidence to make a claim of life elsewhere. But what we can say, and this is something that has changed in the past 30 years, is that the requirements for life, the things that you learn about in elementary school, liquid water, carbon, and usable elements, and usable energy. I mean, that stuff is commonplace. We used to think that the Earth was the only place where there was water. And now we know that Earth is one of the drier places in the universe. There are planets that are almost entirely water from the outside edge to the core. You talk about an ocean 10,000 kilometers thick.
Wow.
And so it's not just that the ingredients for life are out there. they're out there in abundance, and they're out there in habitats that are suitable for liquid water and for life as we know it. So if life is not out there, to me, that's more astonishing by far.
Right.
Than if there was life out there. I mean, I have a hard time conceiving how it could be there and nothing complex like us has evolved. Now, complex, I'm not talking about looking, like you and I, or like your picture.
Right.
But something that has a complex life cycle, that has intelligence, and perhaps has utilized tools to become technical and to develop a civilization, and that can communicate and all that stuff. I mean, the opportunities are there. And if they're not being used, I don't know what to say to that. That's just so astonishing. It just blows my mind.
Right. Well, there's a lot of questions I want to get into with what we're talking about, but I want to start back because we always, for I don't know how many years, we talk Hubble telescope, Hubble, but not a lot of people until the release of these images heard of James Webb telescopes. Can you talk about who created this, and how did they? When was this developed, and when did it launch? And all the questions I'm sure people have.
Yeah, well, James Webb has a sort of a long and complex history. I don't want to get into all of it,
right.
But I suspect that most of your listeners have heard of the Hubble Space Telescope.
Correct, right.
It was launched in 1992, and it's been working terrifically, although we've had a few repair missions, but the space shuttle was able to make some repairs and replace instruments. But most of the really beautiful images you've seen of space have come from either spacecraft that have been up close to planets or from the Hubble. But the James Webb was initially planned for the early 2000s, about 2005, 2006. I remember writing white papers or papers of recommending to the community and to NASA what we should do with the telescope, or a telescope more advanced than Hubble. And by 2007, 8, or 9, I can't remember exactly, we had a pretty good plan, and we had NASA had put money on the table to make this happen. Mm-hmm. But it turned out to be much more complex technically than we imagined, and that led to a lot of delays. We originally thought it would be launched no later than 2010, and here it is, 2022. Right. It's launched actually in 2021, December day last year. It cost a lot more. That has been a bit of a problem.
Right.
And there were a couple of times, I think, that it got close to cancellation because of that. There were management issues. There were technical issues, as I mentioned. Some new technologies had to be developed. So it's not surprising it was more difficult. But yet, the result is the most sophisticated telescope ever constructed. In fact, one of the most amazing technical achievements of humanity is 1 million miles away in space working flawlessly. And it's such an incredible, complex thing. I was stunned that it all works out the way it did. I mean, those engineers that put this together, that designed it and that tested it, went back and forth over data analysis for over a decade.
Wow. I
am in awe of their accomplishments. And I'm an end user. I'm going to be looking at the data. I haven't been involved in building it or testing it.
Right.
I'm interested in that question that you started with. Is there life elsewhere? I mean, I've been thinking about that since I was 6 years old. And James Webb is giving us the data that we need to start looking very closely at the evidence for life elsewhere. And what I mean by that is that James Webb has the capability of detecting the things we're talking about, like water on other planets. And one of the first images of an exoplanet, WASP 69b or 96b, they found water in the atmosphere of a planet. And they're going to be looking for things like chlorophyll and methane. And those are things that we can now look for, whereas before, even with Hubble, as powerful as it was just not there. It just wasn't that capable, as amazing as it was. I mean, what Hubble took 2 weeks to do with a very deep field looking for distant galaxies, the James Webb could do it before breakfast. is what they said.
Wow.
I mean, it's just incredible. And so now we're going to be looking at a lot of the nearby planets that we know of are out there and looking for chlorophyll, looking for methane, looking for a mix of gases, which would indicate life. My guess is that when we find life, the evidence is going to be something that we can't anticipate. So we have to look for a lot of different things, look for a lot of different chemicals, a lot of different possibilities, and for things that look, rather non-life-like, things that look unnatural. I don't want to say that it's not a part of nature, but that it's not. It shows evidence of intelligence. I mean,
right.
That would be one thing that would be kind of cool to find.
Yeah, and in fact, somebody was wanting to know what kind of life would this mean, like plants or micro bacteria or something like that?
Yeah, well, I mean, if you look at our atmosphere, you take a breath, you're breathing oxygen and nitrogen. Right. The oxygen comes from photosynthesis. So right there, if you find another planet that has oxygen and nitrogen, but it also has other chemicals in it like methane, those two gases don't live happily together. They combust. Right. I mean, you've probably heard of the methane torch, but you're breathing in every breath, methane and oxygen, and they're combusting, but it's just a slow rate. It doesn't hurt your lungs. But those two things just don't survive together long. And so if you see them together, that means there's something pumping those gases into the atmosphere. Right. And on Earth, it is bacteria that produces the methane and photosynthesis, which produces the oxygen. But there were dozens of other chemicals in the atmosphere that have a biological origin. And those are the things we're looking for. And those are what we call biomarkers or biosignatures, signatures of life. It's not proof of life. Like proof is something that, as I said when we were talking earlier, is a hard sell in science. I mean, you want to have really, really, really good evidence before you call it proof. And even then, it's not like mathematical proof.
Right.
But nonetheless, we have the ability now to look for that evidence. And we might have some false positives, and that's okay. That's how you learn. But we may have some positive positives. I mean, who knows? You got to look to see if it's out there. We know it can be out there. Right. If it's not out there, we can take it out there. But that still doesn't prove that it's out there.
What popped into my head is, how do you know, and how did they know which direction to point? Because if you think about it, one slight little movement to the left or right is a complete different. I mean, if you think about it, every direction you go is a whole different part of this, whatever we call this universe, galaxy that we're in. I mean, I can't even imagine that. Yeah. Like, I think that's what people can't wrap their head around. It's like the unlimited, the never ending.
I don't know if you have the Hubble Deep Field that you can show, but it's the image that they released. It's actually the very first image they released that the president released in his Monday afternoon press conference. It's the image that shows a lot of small galaxies and a few stars.
Is that the one we showed earlier?
I don't know if you have that one or not.
What's it called?
The Hubble. It's called the James Webb Deep Field.
Deep Field. Let me look it up.
A lot of small fuzzy dots. Each one of those is a galaxy.
I think I found it. So I think this is what really freaks people out.
Yeah, I mean the size is incredible. In that image, you're seeing galaxies whose light was emitted before our sun and the Earth even existed. That's it. And what you're seeing there is you're looking through a cluster of galaxies about 4 billion light years away. And that's the bright objects towards the center. The fuzzy objects are galaxies. Mm. The points of light that have 8 spikes on them, those are stars close to us. Everything else in this image is a galaxy. Our galaxy, the Milky Way, has 300 billion stars. And that's, our own galaxy. Each dot in this picture is another galaxy. In this one image, there are thousands of galaxies, some of whom are 9 billion light years away. And the size of this on the sky, you were talking about pointing, the size of this on the sky is just a tiny, tiny fraction.
That's what I mean.
The size of this is the equivalent of taking a grain of sand and holding it at arm's length And the area of the sky that's covered is what you're seeing in this image. It's just a tiny, tiny fraction of everything that's out there. And I mean, what do you say to something like that? My jaw just wants to stay dropped.
Well, it's actually almost gives me like an anxiety, not an anxiety in a bad way, but more of excitement. Because, but like I said, your thought on, like you said, thousands in that little image, that little grain of sand of looking up into our sky.
Yeah.
But what is your take on, I mean, how far does this go? I mean, are we in some type of a matrix? I know this sounds kind of far-fetched, but it's hard to believe that this is unlimited.
Well, I can tell you what the evidence says, and that is there is indeed a limit.
Really?
When I talked about the galaxies that were 4 billion light years away,
right.
Their light started on its travel 4 billion years ago.
Mm-hmm.
Well, there are some images or some galaxies in that picture that are over twice that distance away, close to 9 billion light years away. But if you go to 13 billion, galaxies will begin to disappear because the first galaxies didn't start forming until a few billion years after the Big Bang, which is 13.8 billion years ago. So you can look far away, but you can't look past that, because when you're looking at 13.8 billion years, you're looking at the beginning of the universe. Now we can see soon after that beginning with other telescopes. If you look at microwave images from the sky, we can actually see and measure the heat that is left over from the Big Bang. But there were no stars there. That was before the stars and the galaxies even formed. So there's definitely a limit, at least that's what the evidence says. Now, it could be that there's things beyond this that we can't conceive of, and multiple universes, people speculate all about that. But this is what the evidence tells us, that there is indeed a limit, there is indeed a beginning.
Well, I want you to explain this, because this was kind of a showing an images of what the James Webb Telescope kind of compared to others.
Right. Yeah, well, the left two images are images of stars in a field of an interstellar nebula. What I mean by that, this is a region where stars are being born. And stars are born out of big clouds of gas and dust.
Right.
And what you're seeing here is a handful of newly formed stars. And they're hard to see. For one thing, they're very small and dim. And the other thing is that they're mostly hidden by gas and dust. Visible light, it's hard to see through it to see what's inside of these clouds. But in infrared light, that's what we normally think of as heat radiation, which James Webb is optimized for. It can look through that gas and dust to see the stars in their various stages of formation. And because it's so big, it can see so much more detail. You can see fine little streamers of gas flowing away from some of the newly formed stars. And you can see the stars at different stages of their formation. You can see planets, or at least the gas disk around these stars that are forming planets, those at different stages of their evolution. I mean, this is literally the kind of improvement you're talking about James Webb versus other telescopes. And it's pretty amazing.
No, it is. And is it just because it's newer and better technology? Like you said, it was bigger, but is it just because of better technology? Because sometimes nowadays, they have these, these little cell phones like this can do what a computer a size of a room did back in the 60s and 70s. Yeah. So is it just because the technology is way better?
It's both. It really is a much bigger telescope than Hubble. It's about 6.5 meters across. Wow. And that's what we normally measure the diameter of the primary mirror in a telescope. Right. Whereas Hubble is just a little over 1 meter.
Oh, okay. Yeah, that's quite a bit bigger.
You get a factor right there of, over 40 just because of the different sizes. But on top of that, you've got some pretty sophisticated image stacking and processing capabilities. By stacking, what I mean is the primary mirror on James Webb is made up of individual hexagons. And so there are 18 individual mirrors that take images, and those images are overlaid on top of each other. And that is that's the beginning of the images that we will see. But the image processing fine tunes that. calibrates it, gives it the different colors that you see, and all the things that are processed is really what requires the technology that we have in very powerful computers now. So it really is both. It's bigger. We have better technology. We have better understanding of how to do this in space. And the best thing is it's working.
Oh, perfect. And I want to show you this because you said that what is behind me. You said this is one of your favorite images. It's like a mountain range, you know, in the universe. Now, is this more gases? What is this image?
This is another stellar nursery. And what I mean by that, this is a cloud of gas and dust that is breaking up into pieces. And each piece is a little bit bigger than our solar system. And each piece will end up forming a star with planets around it. But this is huge. This is, hundreds of times bigger than our solar system. So you'll get quite a few stars that will form here.
Right.
And the bright points of light that are rather sort of pinkish and bluish, those are the youngest stars that have come out of this region. So this is what we call a stellar nursery. It's just a giant cloud of gas and dust, which is falling in on itself because of gravity. And as it falls in, it breaks up into these pieces, and each piece will end up forming a new star and planetary system around it. So it's a nursery. I mean, that's where stars are born. Now, an interesting thing is that when stars die, they go through their life, they take hydrogen, infuse it into helium, then into carbon and nitrogen and oxygen, all the heavy elements that we talk about when we talk about life. And when the stars die, they spew it back into space. And that enriches the interstellar medium and puts more chemicals in these giant molecular clouds where new stars are formed. So it's recycling. It's
like fertilization. It's like...
Well, it's more, I think of it more as recycling. As time goes on, these clouds get bigger and bigger because stars fuse hydrogen and helium, creates heavy elements, which blows that stuff into space when they die. You had some planetary nebulae that you were showing me earlier from James Webb, and that was showing the death throes of a star. As it was dying, it ejected a lot of its outside atmosphere.
Is that it?
There it is. And so in the center here, you actually have two stars that are rotating very close to each other. A young blue star and a cold, relatively cold red star. Well, that red star is dying. And as it dies, it ejects its atmosphere. And that atmosphere is enriched in heavy elements that were built, that were fused together, that were manufactured inside of the star during its life. So there's this recycling sort of at a galaxy scale here that goes on, that most every star does this. It builds these heavy elements, ejects them into space, and then they become part of the big cloud matrix that breaks up and creates new stars. And as time goes on, you get more and more heavy elements in these clouds of gas and dust. So it is a recycling type process in a way.
Well, I know I heard this, that a lot of what we see in these images are probably already gone. And I know this sounds crazy and people are going to go, why would you ask that? But if we could see the past, that something's already gone, can we see the future in other ways?
Not quite where I thought you were going with that question, but no, you're right. Astronomers, in a sense, are historians. I mean, when I look at the moon, I see it as it was about 1.5 seconds ago, because of how long it takes the light to get from the moon to the Earth.
Right.
When I look at the sun, it takes about 8 minutes for light to get here. If you could snap your fingers and make the sun disappear, we would still see it for 8.5 minutes. And our solar system is so big that it takes light about 10 hours to cross. The nearest star is about 4 light years away. So we're always looking into the past. And the further away we look, the more distant in the past we're looking. Now, to turn that around and look to the future, we don't know how to do that. I don't know if that's even theoretically possible, but we just, the future hasn't happened yet, so we can't see its light.
But that's what I'm saying is, if we're here now, then how do we know there's not somebody looking at us that we've already come and gone from the other? You know what I mean? That's why I was like, how is that? That could be possible, maybe. I don't know.
We can't say either way. We don't know. What we do know is that there are there's stars like our sun that are almost twice as old as our sun.
Wow.
And it has planets around it, Earth-like planets, or at least one Earth-like planet that's twice as old as the Earth. So what would evolution do in another 4 billion years on Earth? And that's the kind of planet you have, that a lot can happen in our future that may have already happened on many of the other planets that are out there. Could there be others looking at us and asking the same questions and having a podcast and scratching their heads? Of course. I mean, could there be a million of them or a trillion of them? Sure. I would be surprised if there's not someone out there looking at us.
And I mean, for those people that believe this, that there might be some of these planets that we looked at, because some people are like, I don't necessarily believe that we just came from molecules and created human beings, because we just kind of appeared, 20,000 years ago, 15,000 years ago, that we may have been brought here. Then we've heard this before, that one of those planets may have brought us here because it was dying, and eventually we came here and placed us here to survive.
Yeah, I hear a lot of comments like that. The concept of life being transplanted here or carried here is called panspermia. And that has a long history of people speculating about how life originated on the Earth, whether it was intrinsic to the Earth, it formed on the Earth and evolved entirely on the Earth, or whether it was brought here from some mechanism or some intelligence. The answer is we don't know.
Right.
But what we do know is that from the evidence in Earth history is that the early Earth was too hot for life. It cooled off. As soon as it cooled off, there were oceans of liquid water. And not only were there liquid water, there were chemical signatures that life was present. As soon as the Earth cooled off, there's chemical isotopic evidence that life was present. And the first life, the fossils we have from about 3.5 billion years ago, are of cells.
Right.
And then, a few 100 million years after that, we have things called stromatolites, which are algae mats that have fossilized. And as time goes on, in rocks, we can deduce that oxygen arose in a large amount about 2.5 billion years ago. And then 500 million years ago, that fossil record exploded with new body types, and so on. And so we have a very detailed record of what happened on Earth. You can always speculate, well, could something else have done this or done this? All we can say is the evidence shows that it happened on the Earth, and we can speculate, but that's not science. Speculation is not science.
Right.
Speculation is good, but that's not the science. The science is based upon the evidence.
What does the new images mean for the future of space travel, exploration, even like NASA, and even private industries now, such as SpaceX? And what does this mean when we see these images? Because we're talking about, we might travel to Mars, but now this has opened up a whole new door to space exploration.
Well, it may not do a lot for helping us get to Mars or getting back to the moon, but it's done a heck of a lot in terms of motivating young people to go into science and space science and to become astronauts.
Right.
And now they can do that. You can become an astronaut by buying a ticket if you can make enough money, or you can work hard and become one of the few hundred astronauts that NASA is going to be training over the next few years as they try to build a permanent base on the moon. It's inspiration. I think that's what James Webb is doing for our culture, is inspiring us to understand more about the universe, because we see that we're a part of it. We're not insignificant. What's happened on the Earth and in our solar system is the kind of thing that happens throughout the universe, or at least the visible universe. The same thing happens. We're a part of this all. And how do we fit into it? The kind of questions that come to mind here, that you're asking yourself and I'm asking myself, everybody else are asking the same questions, and they have for thousands of years. They've wondered if there's life elsewhere. But now is different. Now we have the ability to look for it and test our hypotheses, our questions. We can see if it's really out there. It may take a while. We may not know for a few years or a few decades. But if we don't find signatures of life with our telescopes in the next 100 years, then that's probably going to mean that life is incredibly scarce, incredibly rare in the universe.
Right.
My guess is that young people today will live to see that discovery, but that's a complete guess. There's no evidence to back that up at this point. But James Webb inspires us, and it doesn't spur human exploration directly, but it does in terms of motivating people to learn about our place in the universe and become a bigger player in the universe, to expand humanity into space, put permanent stations on the moon, then build colonies on the moon, then build arcs and build habitats out of asteroids that are big enough for 20 or 30 million people, and have basically mobile countries of people that you can migrate around the solar system if you like, and trade among other hundreds of giant arc-like spaceships, or maybe leave the solar system and go someplace else. I mean, the resources we find in our solar system, in the moon, on Mars, the asteroids, there's water, there's metals, all the things that you need for civilization is already there. I mean, it's astonishing that not just are the chemicals for life there, but the raw materials for civilization and technology are there as well. In some cases, they're easier to get on the moon and the asteroids than we can get them here on Earth. So there's a lot of different things at play here. Some things are in our imagination, some things are based upon what we see in pictures, and some of it is just this intrinsic desire to know our place. What is our place in the universe? Why are we here? Is there a creator? Are there other intelligences out there? What are they like? What is in our future? We don't know that, but if we can see what other civilizations have done in their future, then maybe that would give us hope for solving some of our own problems. I think that mostly our own problems are going to have to be solved by ourselves. But if we could see that another civilization has survived this, then that would at least tell us it's possible that we could survive it. Survive the difficult times that we're in now. And
I was going to ask you about that, about our planet, because, right now the record heat all over the world, and, here in California, we're extreme drought. It's getting more, I think wars are going to be more over water than gas, and, all these things. And that's why I remember watching Battlestar Galactica when I was a kid. And it was because it wasn't that the planet became uninhabitable, and so they went to look for a new home. So, like you said, this, I hate to say what it's showing us, that our planet is very fragile because, all these millions, trillions of planets are out there that are no longer here. So, we got to take care of this planet.
Well, the thing is, we have the capability of taking care of this planet. I mean, we can fix all the problems that we've created. Now, that doesn't mean it's easy to fix them or that we'll do it overnight. It might take a century for us to recover from what we've done. But we have to first acknowledge what's going on, that humans have changed our climate, and not for good. And, the contribution of human-induced climate change to the fires out west, the heat wave in England and Europe, is so firm. It's almost at the point of, what more does it take to convince people that there's a problem here, that humans have caused an enormous problem. And if we don't get our minds around this problem and our technology around this problem, it's just going to keep getting worse. And it's going to get worse so fast that our children, our grandchildren, are going to live in a very difficult world if we don't start trying to get and implement solutions. I didn't say it's going to be easy, and it's not going to be overnight, but we can solve this. I mean, we know that we can do it, but people have to acknowledge what's going on, so they'll support the politicians who control the pocketbooks.
Well, I mean, this topic we could talk about all day long, and I think this, like you said, James Webb Telescope has sparked a great conversation and like you said, excitement. And I couldn't even imagine, people probably in your classes and were so excited to see the images for the first time. I remember watching like the president and, other politicians and scientists and their excitement just to see those images for the first time. It was like the kids on like Christmas morning, it's like, yeah.
It really is. It's just like being in awe.
Yeah.
Not just of we've done, but what we've now seen. And also in awe to know that there's much more to come.
Yeah, I'm excited.
We haven't even scratched the surface on the surprises that we're going to have. We know we're always surprised when we have a bigger telescope or
right.
a new spacecraft or a better camera. We're always, always, always surprised at what we discover about the universe. It's like the universe is always one step ahead of us. And I think we're going to have a lot of surprises in store for us over the next few years with James Webb.
When do they expect more images to come through?
Oh, they have a lot more images than what they've released. And so I don't know how they've planned to release them, but you can bet that the scientists are already poring over new pictures, and they're busy writing papers and preparing presentations for conferences. And this information will be released to the public once they make sure that the images are correct and once they've gleaned the best science out of them. And at some point, the public will be involved as citizen science projects.
Oh, that's great.
In studying the data, because there's so much data. But right now, the telescope is still in just the very early stages, and they want to make sure everything is working right. And the people that have invested their careers in it, they want to get a few papers out first.
Right.
They don't want to give it to their competitors who've done nothing to support this.
Right.
And let them get the papers and the recognition. And the people that did this, they deserve a lot of recognition.
No, they do, and we appreciate that. But before we go, I want you to tell everybody about your book. Your latest book?
Yeah, this is the second of two books that James Trefil and I wrote. The first one was on exoplanets, where we tried to introduce to the public the recent discoveries of planets elsewhere. As of this morning, there were 5,120 planets that have been discovered around other stars. And we're discovering new planets, whole new worlds at the rate of about 3 per day now.
Wow.
And this second book is trying to look at what we can say about life from these other worlds based upon our understanding of the laws of physics, the laws of chemistry, and how biology works. And we're not trying to just speculate on what might be there. We're trying to use science to say, how can what we know guide us as to what's possible on these worlds? And the answer is there's a lot possible that we kind of were surprised about. Yeah, it was a fun book to write.
And I'm sure people can pick it up on Amazon.
Oh yeah, it's there.
Perfect. Well, Professor Summers, thank you so much. And, I hope it's not another 4 years before we get you back, but 5 years. Always great time talking to you. I learned so much. I wish I had you as my professor when I was in school many years ago.
I love talking about this stuff. I'm happy to talk to you anytime.
All right. Well, we'll have to have you back maybe the next big release, and you can explain what that is. But everybody, thank you, and please support Professor Summers' book. You can get it on Amazon, and please subscribe and listen to this show and share it with your friends, the people out there that want to know more about the James Webb Telescope and the new discoveries. Like I said, that's one thing we love to find out, new discoveries. And when we do talk about aliens and UFOs, well, I mean, this just opened the door to even more opportunities for that to be true. So anyway, thank you guys for tuning in and being a part of Truth Be Told. Make sure you tune in every Monday at 3 o'clock for Robert Hensley's Men Report. 3 o'clock, Bonnie Burkard doing Transformation of Truth Be Told. And, of course, me every Friday and right here on Truth Be Told. So we'll talk to you soon. And until next time, I'm Tony Sweet. Bye. This has been another episode of Truth Be Told. Thank you so much for watching. Recorded live at UBN Go Studios in Burbank, California. Join us on social media. Facebook, Truth Be Told Radio. Instagram, Truth Be Told Paranormal. Go to Truth Be Told Worldwide for more information on upcoming shows.